Hi, welcome to 3.6 asymptotes. That is such a fun word to say. There's technically more than two types of asymptotes, but for us, we're only going to focus on two, the vertical and horizontal. Your vertical or your vertical asymptote happens when your limit either goes to infinity or does not exist. So I have drawn up here an example of when our limit goes to positive infinity. A case where it does not exist looks more like this. Ooh, that is bad drawing. And this is going to be f of x, 1 over x. So that is a really bad drawing, so sorry. Your left and right limit at 0 don't exist. So one goes to positive infinity, the other side goes to negative, but we still have an asymptote because we get really, really, really close to x equals 0. Yeah, x equals 0, but we never quite touch it. So that's what we're looking for there. Our horizontal asymptote is we look at x as it goes to either positive infinity or negative infinity, not both at the same time. And does our function approach a particular value? So this graph I've drawn here, we have as x approaches positive infinity, it approaches my horizontal asymptote, and that's going to be y equals something. So these are x equals a, y equals some b value. That's where the asymptotes happen. So the one caveat to this is your horizontal asymptotes can touch, or your function, your equation, your graph can touch your horizontal asymptote sometimes, but it'll never touch a vertical. So a case where it'll touch your horizontal. Let's see where we're going to make this. Actually, let's do blue. It can do something like this goes to infinity. We have a funky bump here, and we go to infinity this way. So your horizontal asymptote is more about end behavior, so positive and negative infinity, to where your verticals are just like a hole in the graph sometimes. It's a jump really in the graph. Okay. I really only have one example for this because they're all kind of the same. And for this example, we're going to find the vertical and horizontal asymptotes. So VA for vertical asymptote. If you look at our function here, vertical asymptotes are typically about your denominator. So if you look at this and say, okay, I have an issue at x equals 2. So the limit as x approaches 2, a 3 over x minus 2. How do we want to handle this? Well, let's plug in values that are close to it. I did not get my calculator out. So 2.01, 2.001, 1.999, 1.99. Let me grab my calculator, so sorry. I forget I need this sometimes. So you could probably eyeball this, but we'll be a little more formal one. All right, this gives me 0.748. Toss in an extra, whoops, that is not what it should be. Yeah, okay. I said plus instead of minus. So I'm getting really, really big. My first number gave me 300. Now I have 3,000. Let's go the other direction. 1.999 gives me negative 3,000. And this is more than likely going to give me negative 300. It does. And so we have a vertical asymptote at x equals 2. And you can tell when I graph this. Let me do a really quick sketch graph. All right, so my issue is at 2, 1, 2. From the left, or excuse me, from the right, our numbers that are bigger are going to positive infinity. And if you don't believe that, throw in another number that's really close to it. Come on, pen. There we go. Plug in 2.0001 and see what's happening there. So it tells me, let's do it in gray because I'm going to change this later. From the right side, we're going to positive infinity, but from the left side, we're going to go to negative infinity. So left and right don't agree. Still an asymptote, it's just a different type. Like the graph itself is a little different. Horizontal asymptote, here we technically have to test both. We can see from my crappy little sketch graph there what's going to happen. So limit as x approaches positive infinity, a 3 over x minus 2. Now, if we use a little bit of logic here, as x gets really, really big, my denominator gets really big. And we can see that 3 over a really big number is going to get really small. So let's again do an XY chart. So if I plug in, say, 1,000, I'm going to need, no, I'm not 10,000. So 3 over 1,000 minus 2. 0.003. Now plug in 10,000. 0.0003, and we can keep going. The point of it is we're getting really close to 0. So this equals 0. If we were to go the other direction from negative, we're going to find the same thing. Really big negative numbers are still going to have this approach 0. So a constant over a number that's increasing will be 0. So my graph up here actually wasn't too terrible. Let's throw another horizontal asymptote on here. Now you can have more than one vertical asymptote, but you'll never have more than one horizontal. Yeah, we're good. So yeah, that's what our graph looks like. This is the last bit of graph analysis we have. So things you want to find are your intercepts, your max and mins, your inflection points, so where you change from concave up to concave down, and then your asymptotes. And so there's our last piece of it. You should be able to do this for the you should be able to do the rest of the sections now from chapter 3, just putting all of this together. So I'm going to leave it there.